Hey, welcome back. So in this video, we're gonna be trying to see native Android applications. So if you are completely new to this series, then I suggest you check the other previous videos. We started this from scratch, so you should be able to understand exactly how we are trying to approach things here. If you are completely new to the channel, then you can also check the reverse engineering playlist. So you just have to go into my main channel, and just you're gonna be seeing the main playlist of reverse engineering. You should check that out before you try. For example, um, if you are completely newbie actually and you don't know anything about reverse engineering, then you should check that out. So today we're going to be trying to see two ways on how we can approach native Android applications. Specifically, we're going to be trying to reverse engineer them. So we're going to be trying to see that in a static way using IDA Pro, and we're going to also be seeing that in a dynamic way using Frida. So if you are completely new to Frida, then I suggest you check the previous video just to fully understand how we can do the setup, how we can install the server inside of the emulator, how we can connect the client to the server. So I've explained pretty much everything about Frida, not everything, but almost. I mean, like 10% of how you can how do we say this? Yeah, any newbie should know what Frida is, especially if you're doing mobile security. So you should just check out the previous video to be able to understand exactly what Frida is. So before we start the video, just don't forget to follow me on the different social media accounts, and don't forget also to subscribe and activate that notification bell to get the weekly videos. So yes, I don't know, guys, if you remember this little screenshot that I showed from the previous video, but this one is actually just showing out the building process of APKs. So for the case, for example, of most of the APKs that we have worked along this series until now, you didn't see anything related to this little like diagram, which is C++ source code that is going to be translated into machine code. Now the thing is that most of the applications that we have worked around until now are only just applications that are written in Java code and then just compiled using the process that you are seeing on the left. So there is no native library, there is no native code, there is nothing related to the stuff that is on the right. So just um, just so you can simply understand what I'm talking about when we just say native code. So native code, guys, is just simply referring to the code that can be just executed directly by the machine, specifically your computer. Let's say your computer, your phone, anything that has the capability of executing let's say a low-level code that can be directly executed by the CPU. So we just don't need that intermediate, which is actually the art in this case for the Android, so which is the Android runtime machine. So this code is usually going to be written in C, C++, and like there is a question is like why do we even use it? So well, just simply that the Android development, app development specifically, there are certain components that require high performance, such as, for example, image, video processing, audio processing, gaming too. So for this component, like the use of just simply Java or Dalvik, the Dalvik virtual machines and stuff like that, well, Dalvik code and stuff you're seeing in the left, might not just be that efficient enough just to provide, let's say, a smooth experience. So to overcome like these issues, Android is going to be allowing developers to write these performance critical component in C, C++, which can be compiled into the native code that we are going to be trying to see and try to reverse engineer, and can be executed just directly with the machine. So like this native code is usually faster than Java or Dalvik component, because it's like closer to the machine hardware, so it can take advantage of the low level optimizations like provided by the compiler. Yes. However, there is an interesting fact that You should know also that Google actually doesn't encourage a lot the use of native code in Android applications or app development in general because it can like introduce some security risks and make the applications more more difficult to maintain and update, and at the same time more exposed to some common pretty common vulnerabilities in security we know, such as buffer overflow, heap overflows, those kind of top 10 WASP that you see almost in any kind of postal shitty LinkedIn post. Yeah. Anyway, so nevertheless, so there's also another interesting thing, which is that some malware authors might not just care about these users. They are malware authors, so they won't give a shit about what Google is saying. They're gonna be just doing what they want. So may use native code just to create malicious apps. And one important aspect to consider is like there is that working with native code is generally more challenging than working with Dalvik bytecode. So this is just due to the fact that Dalvik bytecode verification makes disassembling and analyzing and anything just related to those analysis is just straightforward. But the bytecode just follows specific properties that enable easier just disassembling and analysis just using JDEX. So we already saw that in the previous video. So the previous video we tried to do that, and you see that you almost see the decompiling of the Java APK is almost the same as the source code. Almost. Not the same, but almost the same. But I'm not going to be talking that there is some kind of obfuscations or something like that. So, on the other hand, when you try to disassemble machine code, it remains a significant challenge, as we already have seen in the main reverse engineering playlist. So, when native code is used in Android, like it becomes difficult to disassemble and decompile the code. That's something that we see a lot. I'm gonna be trying to see also in this video. So this will makes it like a great trick for attackers, as it can make it harder for security researchers just to analyze the code, I think. Um, and the use of native code also provides a great like place for code obfuscation too, which means that anything you can do like in a normal like binary or a normal program in your computer, you can just uh, take your tool set and just apply that on the same platform, which is now going to be mobile or just phones. They're going to be just throwing the same obfuscations into your native code and then just link your native code um, to the Java code, and then your application or your Android application is going to be having the same security mechanisms, or the same attacks, since actually the native code is going to be interacting with your Linux operating system that is like working deep down the Android. So you're gonna be just more actively interacting as if you are interacting with a Linux computer machine. So the only difference is that Linux is going to be communicating with the upper layers, so you're mostly going to be attacking just Linux directly. So yeah, so it's really important just to analyze the native code, as well as also, guys, it may contain vulnerabilities, as I have already said. So the analysis of Java code also can be misleading. So when native code is like involved, as the Java code may call native functions that perform actions that are not visible in the Java code. So maybe there is some native code that is working behind the scenes. So you should be also able to understand that. So, in Android, generally, guys, like both Java and Dalvik code and native code run within the same security sandbox. That if I suppose you remember that sandbox that I have already just talked about in the previous video. So this means that even though native code has the ability to interact with the system at a lower level than a Java and Dalvik code, it will still operates within the same security restriction as the higher level code. So yeah, but there is a little thing like the Dalvik code and memory. For example, native code can modify memory data structures, which could, for example, potentially cause the Java code to behave unexpectedly or even crash. Additionally, for example, an attacker could like modify the native code to change the behavior of the application at the runtime. You can add, for example, to that, for example, like everything runs at the same user. So, any malicious behavior within the native code can potentially affect the entire system. So, including, for example, other applications and the user's data. But like, this is the important thing. Like, how does this Java code is going to be communicating uh, with with this native code. So to enable a communication like between Java and native code, so this little guy right here, which is the GNI, which is actually in a Java native interface, that is going to be used to do that. So basically, whenever a Java code wants to communicate with a native code, for example, it says it wants to call a method from the native code, it needs to be it needs to be doing that um, by the GNI. So the GNI is going to be the bridge that is going to be letting the Java code communicate with the native code. So for example, I have here an example of how we can do that. So mostly we're gonna be when we are gonna be developing something in native code, we're gonna be using C++. So I'm gonna be including gni.h, which is the header file. So gni export gent is gonna be the return of this method, and then we have the name of the method that starts with Java, my package, my class, add two numbers. So Java is actually just to say that we're going to be using the that this is actually going to be GNI call, and then we have different parameters I'm going to be trying to explain to you, and then mainly the job of this function is just to simply return the sum of number one and number two. Now we have ePackage that is going to be, this is from the native side, this is from the Java side. So we have a package, we have a class, we have a declarator, we see that this class is declaring like a native method called add two numbers. So that's going to be taking number one and number two. And we have also static. That's going to be loading the library that will be containing the native code. So here's the thing, guys. When you are trying to develop any kind of applications, if, let's say a native Android application is going to be actually using a library. So this library is going to be containing the native methods or the native functions that you have or that your Android application is going to be using. So once you know that, you will actually see this loading of library that is going to happen that is going to be happen inside of the Java code, just to make sure that this library is loaded is loaded with the when the application starts, and mostly you're going to be seeing that in the main activity. So we're gonna be trying to see that like with the application that we're gonna be trying to work on today. So mostly you're gonna be seeing this load libraries this thing inside of the main activity. So the thing is that he's gonna be declaring that one as add two numbers from the native side, and then just load the name of the library that is going to be containing all the methods. So we're gonna be just supposing that in this case we only have one method. So the next thing that we're going to be also trying to see is, so let's suppose this is the way he's going to be calling that function. So he's going to be creating an object from the new class that we have just created, and then the result is going to be my object dot add two numbers and then two or three, and then just show you the result. So the question that can be arised in here is that what is this GNI export? What is this GNI call? What is GNI add? What is G object? G and G end, which just simply means that they are two integers. So, but this GNI call and GNI export are really interesting. I mean to be able to know them. So well, we will start with the GNI export. So the GNI export is a macro, so you'll mostly see that a lot in C++ if you have some knowledge around it. So by the way, we have a video. I think I have a video in reverse engineering C++ that can show you a little how things are happening in ELO level sites. You just have to check that video out. Just type in reverse engineering C++-IDA. I don't want you just be having that video in front of you. You just can watch that if you're completely newbie to C++. It's not an advanced video, but it's a good one. Yeah, so this macro is going to be used basically just to tell the compiler like, hey, like this function should be exported as a symbol in the shared library for Linux or as a DLL, for example, for Windows, because mostly um, when we're talking about this library specifically that we are trying to create out of this Android native Android application is going to be either for Linux or for Windows. Why? Simply because at some point you might be exposing that as a DL you might be exporting that as a DLL. So who knows? So which is the dynamic library for Windows, which means that you can use that native code even for Windows. You just have to be having the GNI interface. You need to find a way on how you can interact with GNI interface with Windows, and you can simply use that native code too. So you can inject it inside of your applications even on a Windows. Um, so yeah, so that can also that library can be accessed by the GVM obviously when the library is loaded. So one thing just to note is that the GVM is responsible for loading the shared library since it's going to be used, while the functions within the library are then accessed obviously so the GNI interface. So it's not the one responsible for executing the code. It's just only responsible for loading and accessing the code. The other next thing that we should also care about, which is the GNI call, just a macro also that specifies the calling convention for the native method. So the calling conventions, guys, is the way on how we are going to be calling methods. So the calling conventions is a set of rules, as I have already just told you, that determines how the arguments are passed and how the return value is returned. So in general, the calling convention should be set just to match the platform default calling conventions. For example, the 8086, the 8664 calling convention, the ARM v7 calling convention. So it depends on the CPU architecture. So it's mainly related to that. So the other thing that we also have is the GNIM. So it's a pointer. So, well, with a little bit, just with a little, with some knowledge around C, you just know that this is a pointer, so that is going to be pointing on this little data structure that we have in here, which is GNIM. So you can check, by the way, with what this GNIM is having as attributes inside of it, just by checking the Android documentation, just to fully understand what it's going to be pointing to. And mostly if you're going to be wanting to check what the env is having, you just, since it's a pointer, just with some knowledge in C, to access an attribute that points to access actually an attribute inside of a data structure that is pointed to by a pointer, you just have to add this arrow here. Yeah. So yeah, so for example we have get string UDF chars is going to be converting just Java strings to C style strings, and Copilot is doing a good job right here, just adding those little comments right there. Anyway, so this is going to be just a data structure that is going to be pointed to by this little env variable. um, and then actually the GNI actually structure data structure is going to be providing various functions and data structure that are used by native method just to interact like with the GVM and the Java objects and classes that are used like by the application itself. For example, guys, the GNI structures just provides functions for creating as the one you have seen. Just this little one that was in here, which is for example get UDF chars. And there is other interesting functions you might also and methods you might be interested to see. It depends on how you're going to be using that. So yeah, I think now we almost have like everything related to the GNI, so you can just learn more about that if you try to go and do your own native applications. So this is the best way to be able to learn how to build things. You should be at least trying to build that native application at least once in your life, just to be able to understand what I'm talking about. So yeah. So I'm gonna be now just getting right of that. So we're gonna be passing now to the challenge. So today's challenge is an application called Boxy. I'm gonna be installing that Boxy. So adb install Boxy APK. So we are installing Boxy on the emulator. So today I'm gonna be using the main Android emulator for Android Studio. I'm gonna be trying just to show you that we can do the same thing. Doesn't matter if you're using BlueStack, Jimny, Motion, whatever. So you can just do it. So I'm gonna be just using my rooted emulator right here, which is an Android emulator, just by the Android Studio. So I have successfully installed Boxy. I'm gonna be just trying to see what Boxy have inside of it. So it's just asking for a username, password, and then you just need to type in validate. So suppose I'm gonna be saying AAA BBBB and then just validate. So access denied, wrong password or username, try again. So it's mostly another crack me, but in an Android fashion. So you just have to be able to understand what this Android application is going to be doing. So I highly suggest that you try to do the solving part on your own. Then just come back to this video just to fully understand. You need to give it a chance alone. That's the spirit. You need to give it a chance alone. So you're gonna be finding in the description a link to the Boxy method. And just don't forget also to give a star to that GitHub repo that is containing all the challenges to make sure that the that repo gets more attention, especially for people who loves challenges. Yeah, so we have fully installed now the application, and we are going to be seeing what this application is having. So I'm gonna be just going with the usual flow that we usually just do. So we're gonna be just opening up the explorer.exe just to get the application. So this is our Boxy right here. So he is loading Boxy inside of it. It's gonna be taking some time, but soon enough it will be there. Soon enough. Yeah, it's over. So the first thing that I'm gonna be trying to see what the manifest has inside of it. So we see that the package name is com example Boxy. Permissions, dynamic receiver not exported permission. Application, so user SDK is 24 minimum, 35 maximum. We have some interesting receivers, so that means that this application is going to be receiving something. We also have some providers, and we have the main activity, which is that's usually going to be having the intent filters of main and launcher. Yeah, so there's not a lot of information that is interesting in this manifest file, so maybe we go and check out the main activity. So we have the main activity right here. So it's having, as you can see, a native library that is called checkred, and he's loading some interesting library called Boxy. And then we are seeing actually the life cycle of the main activity, which is going to be calling the onCreate function, creating some buttons and text fields, and then when you do click that button, it's actually going to be getting the text from this little guy right here. I suppose this is like the username. This is supposed to be the username. We can just call it username, and this is like the password. So he's going to be getting the password, and then he's going to be passing down the password and passing down, I suppose. Actually, right here is not point. Yeah, so this is like the username. So user name one. So he's going to be passing username and then password. So to the check reds, that is going to be saying we either welcome or access denied. So we can try, for example, let's suppose this application is actually having another home page after it. So this is more like a login page. This is more like a login page where you have to just simply go and try to see, let's say for example, if you validate that right, there is some kind of home page after it. So it's going to be taking you to your profile, and you want to see what this homepage is having. So I'm sure that there's some kind of information that was supposed to be loaded to you by the server, since those informations are like saved there. But let's suppose there is a homepage and you want to go there. So I want to just bypass this validation and just make sure that I want to. I get this little message that's saying welcome user one, correct credentials. So the goal of that, I'm gonna be trying to use Frida. So as you have as you've already like seen in the previous videos, uh, I want to intercept the onClick method, and I want to change it in a way that it can also intercept the native method. So this video is just mainly about understanding how you can hook native methods, how you can intercept them, how you can see the results of what they are returning, how we can also override the return address, not the return address, the result or the return um, of the function itself. For example, in this case, we have check credentials is going to be returning boolean value, which means that it's going to be returning either true or false. So if you are able to change that, then you can play around the logic of the application. So I guess I'm gonna be using Frida first to see all the exported. I'm gonna be assuming. By the way, guys, I'm gonna be just assuming now that I don't have any like knowledge on static analysis, especially in machine code programs. In this case, if you go into the library and if you go into 8664, this is the shared library that the application is going to be using, or the Android application is going to be using. So once you understand, for example, this machine code, so you need specifically to reverse engineer the this shared object or shared library, and then go and try to exactly understand what this code is doing. So I'm gonna be just getting rid of that one. And once you reverse engineer that, you might be able to understand what are the username and password that your application is requiring to be able to just pass to the home page. Yeah. So, but I'm gonna be doing that in Frida style. So, I'm gonna be trying to script that. So, this is like hook.js. So, if we go and try to see, for example, Frida-UA, so it's going to be showing us what are the different applications. Frida PS, I'm sorry, Frida PS dash UA. It's gonna be just showing to us the different like applications that are running on the emulator that we have. So we see that Boxy is running right here. So yeah, that's it. So I'm gonna be trying to see, guys. Now I'm gonna be trying to see the documentation and how we can play around Frida a little, just because the documentation is really important. So I'm gonna be going to check the JavaScript API. And yes, so the first thing I'm gonna be trying to see is I'm gonna be trying to see what kind of functions this application is exposing or exporting. So, which means that, for example, this little shared object right here, guys, is going to be exported, right? So maybe I need to be able to understand exactly or know exactly what is the name of this little method. So I want to know, just from, for example, a perspective of analysis, I want to know the exported functions. I want to know the important functions too. I want to know this kind of informations because they are really important for me just after, because once I understand what are the exported functions, what are the important functions too, I can understand what is the behavior that is going to be working, since now we've already like understood the logic behind the application, which is going to be asking for a username and a password. But we need also to understand, for example, how we can hook those little methods that we already saw, which means that in this case, there is no method, there is no Java method that is going to be doing the logic. There's a native method, but we don't have the implementation of that native method in front of us right now because it's already implemented in this shared object or shared library. So but we need to find a way on how we can see at least the result in front of us, how we can hook it. So this is the goal of the video, is to understand how we can hook native methods. So the first thing I'm going to be trying to do is I'm going to be trying to check the exported and imported functions. So to do that, I'm going to be just using a variable var. There is going to be libboxy that is going to be having like module.find base libboxy, but not I'm gonna be using find base address. I'm gonna be using a process. So process dot wait a second, just process dot get module by name, which is in this case the module name is going to be libboxy.so, since in the different libraries as you can see, which is the same one, which is libboxy.so. And then the next thing I'm gonna be trying to see is I'm gonna be trying to check the libboxy base address, uh, and that's it. Then the next thing that I want also to see are the exported functions. So I'm gonna be just enumerating the exports, so you can just go and check that one, for example, if you want in the documentation, in case you want to know what this one is going to be doing. So it's going to be enumerating exports of module returning an array of object containing the following properties, which are the different functions that the this little library is going to be exporting. So yeah, so I'm gonna be just iterating through them, and then we can also find like var imported functions that is going to be enumerating imports instead of exports. So yeah, I guess this is uh, this is perfectly well, I guess. So now, how can we run this little script that we have in here? So it's pretty simple. Type in Frida, type in U, type in N. In this case, because Boxy is already running. So, and then you just hook this little script that we have just created, which is hook.js. So you run it, and then it should be just connecting to the emulator, just attaching it, and then you see the libboxy base address. This is the base address of the native application, and the exported functions are java.com example boxy main activity check cred, which is at this little address. And with the important functions that we have, which means what are the imported functions that the Android application used, which are actually I mean in this case the library itself. What are the for example, when you write a native library, suppose used in this case, as you can see, as a string compare, string length, stack check fail, which means actually it's just going to be checking the stack canary, and CXA finalize and at exit are just functions that are going to be used also. Register at fork 2. But what's really interesting is that we see that he's using string length and string compare, which means that he's going to be taking the length of something and then comparing with something, which makes sense because there is a validation process inside of this little Android application. So the interesting thing, for example, is that we need to be able to know the method name, which is in this case check red. So this is actually the method that we want to hook. So now once we know what are the important functions and what are the exported functions, we can try, for example, to hook this check cred. So I'm gonna be going back to JDEX. I'm gonna be going and try to see where the check cred is called exactly. So check cred is called on inside of the method onClick, and the onClick is actually called in anonymous way. So in an anonymous way, which means that it's not called inside. It's called inside of the main activity, but it's called inside of another method, which is in this case onClick. Is mainly when you do the onClick way, you can go and check, for example, how this thing is done from a developer side, Android. So yeah, you just need to switch up to English because it's using my location again. Okay, so is there like anyway? So maybe we can also like oh, wait. I want a concrete example. Yeah, maybe this one is having exactly what I want to. Yeah, as you can see in here, for example, on-click listener is created, and it's actually the one that is going to be just triggering out when you do a click on something. It's going to be doing specific things. So The onClick is just the name of the method, but in this case it's going to be using this little guy right here. So that's why, for example, when I'm gonna be going back, I'm gonna be just commenting all that, just getting the code that is going to be performing the hooking process. So um, we have this little guy right here, so I'm gonna be just making sure that ends there. So the target class is going to be example boxy main activity, and this is how you can actually call the anonymous function that I'm talking about, which is the $1. In this case, it's this little guy right here, which is this one. The logic that is behind the scenes, which is related to this guy right here, which is this one, the onClick listener. So once you do that, I'm gonna be trying. So now the target class onClick that implementation, and I'm gonna be just trying to see in this case the onClick. So I'm gonna be trying to re-implement the onClick logic, which is going to be having a view. So I don't give a shit about the view. And it's going to be calling the original method, so I don't need that too. So it's just I want one click is called, and I want it just one click is called. That's it. Yeah. So this dot on click view just to make sure that we call the original method. So once we try to do that now, for example, I'm gonna be just getting rid of that one, and then I'm gonna be getting that back just to show you something really interesting. Okay, so if we go back to Frida, whenever I change something inside of the code, I don't have to exit and go back, so it's simply gonna be on real time changing also that. So if we go back to the phone, it's attaching that to the phone, and then now it's perfectly working. If we try to press validate, as we can see, one on click is called, which means that Frida is perfectly hooking to this Java method, so this is perfect. Now, what we want to know is how we can intercept the Java native or the native Android application, or the specifically the native code, or the in this case I want to intercept this check credentials method that is native. So I'm gonna be going back to Frida documentation. I'm gonna be typing interceptor, interceptor. Yeah. So this is the interceptor. There's a code that should be in here, so that can help us like do. As we can see, interceptor is just going to be helping us just call a function at target. So we have this code which is going to be attaching which was going to be attaching the interceptor to the method that we want. So we just have to give it the library that we want, the name of the function. So we get export by name. So that's why we need the full name of the method, the native method, which is, for example, in this case, we saw it as starting with Java something, and then on enter it's going to be doing something, and on leave it's going to be something. It's going to be doing also something. So it's really important to know that. So we can just take that code then just use it directly, I guess. So I'm gonna be just getting back to this one. So onClick is called, and we have this little guy right here that is going to be used to. Yeah. So in this case we have libboxy.so, and I want specifically to know the name of the whole method that I want to export. So I'm gonna be just going back. As we can see, it's this little guy right here. So now I can just comment that and uncomment that back, and then just type in Java boxy activity, and on enter it's going to be doing something, um, which is in this case I just want to say that console.log. So java com_cred is called, which means that we have intercepted that one. So I'm gonna be just taking that off too, and then try to see now how we can use it. So maybe now we can just try and see how this is working, how the interception is going to be happening. So validate. as you can see, there's an error. So type error, not a function. So not gonna be using that one. So I'm gonna be just using this called as f. Okay, we can just call that f, and just came back right here and say that f is going to be var f is going to be not this one, but actually this little guy right here. So I'm gonna be just creating libboxy as a variable, and no, I don't want that. So yeah, libboxy is to get the name of the export, the exported one. Let's just take that one. So get export by name, which means that now this little f is going to be pointing out to the informations of this native method that we have, and then we're going to be using that in the interceptor attach. So I suppose now that should be working. If we try to relaunch that, on click is called type error, not a function. Hmm. Okay, so we just need to figure out exactly what this thing is about now. Yeah, maybe if we go back, try to see the documentation, I guess. Is there like any idea how we can like solve that issue? Interceptor dot attach. Yeah, yeah. There's this little code there isn't here. Maybe we can use that. It's a better one. The thing is that I have an issue, which is actually like the module name is not perfectly working well. So yeah, so in this case it's this one, in this case it's this one. Yeah, so now what about that? Now we don't need that one. Yeah, Java com example boxy main activity check red. It's perfectly fine. And then on enter is going to be calling this little function right here, so which is perfectly good. We have like something. The boxy. I suppose this should be working. Just maybe let's go and try to get module by name, get export by name. Yeah, maybe this is gonna be working. Maybe let's try to see that one. Touching. Yes, so on click is called. So let's see what we have now. The thing is that, guys, as you can see, now there is no like syntax error or something, but there is an issue. The issue is that when we try to intercept the onClick method inside of the code, it's not intercepting the native code even though we have clicked the bottom. So the issue here is just simply, guys, that the library, which is the native library, is loaded, but the method is not triggered. Why? Simply because we haven't called it, so we just need to be calling the function itself, because the function is going to be executing the code, so we should do that. So once I do now, for example, validate when I just have called the onClick method, which is going to be actually calling the native method or the native code, it's going to be showing that one. So I suppose we have an issue, I guess. Yeah, as you can see. So yeah, it's just it was just crashing a little. But as you can see, we have Java com example boxy main activity check red called from that point, which means that we have fully intercepted that native method. We have hooked the Frida with that native method. Now let's suppose, guys, now we're having a lot of OKs I need to answer. Yeah. Now validate that one. Okay, now it's perfectly working. Okay, now I don't want that message to be honest. I just want to say that I have intercepted that perfectly, and that's it. Just I don't need that one, so intercepted. I don't have to be okay. So now, guys, we have intercepted the method. Let's suppose I want to be changing the return address. I want to be seeing also the return address. So I'm gonna be adding the on leave now. So on leave, so that is going to be, I want to be checking the return value first. So this is a really important step for me. So now if I want to be seeing the return value, I'm going to be just going back a little and then press validate again. And as you can see, the return is 0, which means false. So I want to be changing that one. So I'm gonna be saying return value replace to 1. So just have to replace it to 1. And let's see what we can do now once we replace that one. So if I try now to press validate, it's saying welcome and the credentials are correct. So we have like tried to play around the application, which is really interesting. So now I suppose if I'm gonna be having a real application, then this application is going to be taking me to the home page, which is a good thing. Now, this is how you can, for example, solve this challenge, and you just have successfully just solved it, I suppose. But I'm going to be also adding another interesting part, which is how I can fully reverse engineer this process and just generate, just know what are the username and password required for just by fully reverse engineering the library. So to do that, I'm going to be using IDA. You just have to go inside of the so I can now just quit Frida. I'm gonna be just using APK tool to unzip the application. So java.jar APK tool decompile, and then you just give it the name of the application, which is in this case boxy.apk, which is already existing. So if I'm gonna be explorer.exe boxy and open up that one. I'm gonna be just going inside of the libraries 8664. I find that this one is really just easy for me to interact with, better than the ARM64 and the ARM v7. But in this Android series, we're gonna be exploring ARM together too in the next videos too. So we go into the 8664, just drop it inside of IDA. I'm not gonna be checking anything specific, just using the default settings. Then okay, so it's analyzing, so it doesn't take a lot of functions. And as we can see, there's this little check method that is in here. So there's no applications on this native method, so I'm not gonna be having a lot of pain just to analyze. So it's just a small function, just a small method. If you press F5 just to decompile it, as you can see, this is the 4 parameters. You can already anticipate what this parameter is, and this parameter is, and this parameter is, and this parameter is, just from the documentation. So this is the GNI this is the GNI call, not the GNI call, the G object, I'm sorry. And this is like the username, this is the password. So this is just going to be user, this is password, this is password pass. Okay, so as you can see here, there's this logic that is happening. So I'm gonna be just taking down, we see that there's some kind of XOR PS region. So there's this little two guys in here. So we have V7 and V8. V7 is going to be pointing to the A1 user pass. So mostly this is gonna be the username, and this is the password. So this is just passing down those parameters into other local parameters or local variables. I'm sorry. Yeah. So he's going to be checking the username length, and then he's going to be doing something. I'm going to be ignoring all that things that's just supposed to be initializations on something, and then we can see that there's this little guy right here that is going to be initializing v10 into 0. That means that this is just simply a counter. And then just taking v9. What is v9? v9 is a value that is already pointing to the length of the username. So yeah, so this is just the length of the username. As you can see, this the process of statically reverse engineering this code is just simply about renaming things. Yeah, so once you do that, you have, as you can see, v15, which is going to be compared with the password. So actually, it's taking the username and the password and generating a password based on the username, just comparing the password that you gave with the password that was generated. So it's simple, simple, simple challenge, I guess. Anyone can just solve. Anyway, so this is this is the generated password, I guess. Yeah, and it's just taking the username, exporting it with 4 users. So it's a simple one-pad encryption, so we can just solve it directly. We go into File, we go into Python. No, I want you, Peter, please. Notebook, yeah. So the key is 0x42, and the username is, for example, I want to find a password for, let's say, Mike, and password is going to be that one, and for and not in the range of username. Actually, I want length of the username. Yeah, so password, yeah, so key plus equal, so not key, I want password, please, plus equal to the or not one, and I want to XOR it with key. uh yeah, so decrypted password, gonna be using that one, that environment Python. No, 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 no. So it's connecting to the kernel. Yeah, so this is a CHR of this little guy right here. Password is that one, so we take that. We go into the application. I'm gonna be just 3 days off. Yeah, Mike. Okay, just need to paste that down, please. Please. Okay. Is there like clipboard? Yeah, there is. Yeah, welcome, Mike. So it's simple, guys. I guess we'll learn something really interesting in these videos. We learned how to hook native methods using Frida. We learned what are exactly native methods and how they are called inside of the Java code. I hope you learned something new out of this video. See you in the next weekly video. So you keep hitting that sub button if you are new. You go back and check the reverse engineering playlist if you are completely new to reverse engineering. And don't forget just to activate that notification bell to just get the news, I guess. Bye to the next video, guys.